Hello and welcome to this special presentation of the Channel Company, the new data center, high performance in cloud servers. You know, the data center has certainly changed. The move to virtualized hardware, consolidated servers, and more computing in the cloud has fundamentally altered how data centers are built and used in today's enterprise. Today's businesses are looking to lower their IT costs, but at the same time, get more performance out of their IT infrastructure. And luckily, technological advancements in the data center have enabled solution providers to deliver more powerful and cost-effective server solutions. Today we're going to examine how Intel Xeon processors are helping solution providers to leverage the latest data center growth areas, including cloud and high-performance computing. Today's presentation is live and interactive, so we invite your questions and comments at any time, and you can submit those using the Ask a Question button there in your viewer console. We're also going to encourage you to disengage any pop-up blockers that you have in place, as we're going to be pushing out a brief survey today, and one lucky viewer is going to be receiving a $100 Amazon gift card, and you will be notified after today's event. So you want to keep watching the phone for that one. Hello, everyone. Thanks for joining us. My name is Jonas Tischner. I'm the Director of Content for the Channel Company. I'll be your moderator for today. And we've got a couple of very special guests. Joining me is Managing Editor of CRN, Rob Wright. Rob, thank you so much for being a part of today's conversation.
Thanks, Jonas.
We also want to introduce Bill Elwell, known as the server guy for Intel. Bill, looking forward to hearing from you as well in just a little bit.
Thanks for having me.
We're going to start today, though, with Rob Wright. And, Rob, I know that towards the end of last year, CRN put together a POV study that really gave us strong indicators for where the cloud sits in the channel. It's very easy to point to both migration and cloud adoption excuse me, as being front and center. So today's discussion from an editorial standpoint is really extremely relevant for the times that we're in right now.
Yeah, it is, and I'll just kind of start out with sort of a brief overview of some of the trends that we're seeing at CRN, and that obviously we have some data points here in this presentation from places like Gartner and IDC that help illustrate those trends. But essentially, the point of this discussion is looking at some of the changes in the data center and how they're affecting sort of the technology out there. And one of the things that we see happening, obviously, is with the move to cloud, virtualization, high-performance computing, HPC, and just all of the sort of the different types of application-specific servers out there, the data center is becoming a lot more complex. It's becoming a lot more sort of task-oriented. It's no longer about sort of dropping off the big iron servers and integrating them into the existing infrastructure and kind of letting the customer figure out how they're going to use those servers and the server capacity. Now, you know, the servers might not even be in the customer environment anymore. They may be in your own environment if you're a solution provider. They may be in a third-party cloud service provider. And that's putting the stress on the ability to build and produce servers that can handle those application-specific tasks, that are more scalable, and they can adjust the peak capacity times for bandwidth, or can adjust on the fly to more intense workloads without overheating, and can do the kind of really heavy data-intensive tasks that we see a lot today. And you know, this first slide here, you know, the cloud migration, everybody knows that cloud is accelerating. It's something that everybody's talking about, and if they're not talking about it, then they're actually deploying it. And this is an interesting data point that came out from Gartner not too long ago. Gartner predicts nearly half of large enterprises will have deployed hybrid clouds by 2017. And that's important because we're not talking about just public or private cloud. We're talking about a mixture of clouds. So there may be dedicated private clouds being hosted by a solution provider, built by a solution provider, and also use of public clouds, whether it's software as a service or, you know, infrastructure as a service from larger vendors like Amazon, Microsoft, Google, what have you. And in the past 3 years, more enterprises have looked to lower IT costs through the cloud, and that's been a big driver. I mean, the cloud has been seen as sort of this cost-cutting tool to be able to outsource, those data center, that infrastructure cost that so many enterprises and small and medium-sized businesses too have to deal with. On this next slide, private cloud is also maturing. This is also from Gartner. And Gartner reports now that 50% of large enterprises have a private cloud deployed, and that's pretty interesting. So that's not just relying on a cloud app, a cloud-based email, a cloud storage solution. I mean, sometimes you see a lot of data coming out about how many businesses are really using cloud. And I mean, let's face it, we all use cloud in some capacity if you're using Gmail or some type of Dropbox or storage account, Amazon storage or what have you. So it gets a little skewed. But when you start talking about private cloud, that becomes a great deal more sophisticated. And it's usually if a company is making the investment in building a private cloud, whether they're having a solution provider doing it or they're using their own IT to build it. It's not just for some simple email server. It's usually they're going to build a fair amount of their IT operations inside of that private cloud. And also, only 11% of large enterprises polled say they have no cloud plans through next year, and that's pretty significant. So it's a very, very small percentage of companies out there that are not looking at cloud. And whether it's public or private cloud, and this is an important distinction to make, and Bill's going to touch on this later, is just because an enterprise is moving a part of their infrastructure, their data center to the cloud, does not mean the servers are going away and that workload is somehow being magically transferred to other servers. No, it usually entails adding more servers and more server capacity to handle those cloud tasks. And with that it comes with some very complicated issues. You talk about power management, thermal issues, being able to make sure those data centers are actually running cool and at optimal performance without overheating, without having to shut down. A lot of people, I'm sure, on the call here have seen some of the recent cloud outages that we've had and some of the high-profile ones, and some of those have been caused by the fact that the data centers that were hosting the cloud could not keep up with the power needs and either overheated or just shut down for whatever reason. And it's an important thing to remember when you're looking at the amount of capacity and the amount of infrastructure that's being moved into the cloud. This next slide deals with colocation services, and it's a growing business. And this is something we're hearing a lot more about from solution providers that we talk to at CRN, and this data point is from IMS Research. They say colocation will become a $10 billion market in 2017. Now, that involves a lot of different things. It's not just hardware. It includes services, software, et cetera. But one of the things they pointed out in their research was that the growth is reflecting strong demand for multi-tenant data centers, that's important. That goes back to the point about optimized servers, making sure that they can run and handle different fluctuating capacities and different demands, whether it's applications or what have you. Maybe it's just a simple storage. But being able to sort of juggle all of those balls and make sure that they're operating at an optimal performance in those multi-tenant data centers is really, really crucial. This next slide here, infrastructure as a service boosting the server market. This goes back to what I said before. Just because the servers are being moved to the data center, the server capacity and the infrastructure in some of these businesses are being moved to the cloud does not mean that they're not tangible anymore. These are real servers. They're being added to whatever data center that the cloud is being hosted on, and that's really crucial because the cloud market, and this is something that we've written about a lot at CRN, we've written about for years now, it's really maturing. We saw the growth of cloud sort of take hold with different types of applications, cloud applications, and sort of simple cloud storage. Now it's really maturing now to more infrastructure as a service. In fact, there was news today that Verizon just introduced their enterprise cloud platform for infrastructure as a service, and it's becoming a very crowded field when you look at all the different players out there on the vendor side, and then you have a number of solution providers that are major solution providers that are also doing the same thing. And it's really, Gartner's pegged this. Actually, this slide, and that's a typo, unfortunately. This is actually a data point from IDC, but both Gartner and IDC say that infrastructure as a service is one of the fastest growing cloud areas out there, and IDC has said that it's growing at about a 27% compound annual growth rate. That's pretty impressive. Next slide here, high performance computing also driving sales. So in addition to cloud and sort of the need to have handle virtualized server demands, IDC says that HP server sales jumped about 8% in Q2 to $2.6 billion. And this is important because Q2 the server numbers were down a little bit. For the HPC servers, unit shipments increased 34.7% to about just over 31,000 in Q2, and that's really crucial. When we talk about high-performance computing, it's not sort of just these big supercomputers that are residing in the federal government or academia. There are a number of different businesses, different verticals out there that are deploying HPC servers to handle specific line of business items, especially around analytics and big data. That's becoming a crucial area. Very, very intense server tasks that are being deployed and it need to be handled by something that can actually produce sort of high performance level optimization. And this slide here, shifting server market. Like I said about the previous slide, there was a bit of a dip in some of the worldwide server market numbers for the second quarter there. IDC reported a 6.2% decline in the server market, but this is the real interesting part. So the overall market, it did dip, but when you look at where the market growth is, it's around density optimized servers according to IDC, and that's hyperscale server environments. And that jumped 26.6%. That's really interesting. And that's important to note because, again, it's not just about deploying servers and dropping the big iron off and, hoping the customers know what to do with it and, giving them entry-level servers. And, there's still a lot of that out there. But as I said before, the data center is just growing. It's becoming more complex, and there's a lot more specific needs for both power management and optimization. And again, big data, bigger data centers. This is one of the things that is really contributing. We talked to a lot of solution providers. Is really one of the things that's contributing to data center growth. The guys that we talk to on a regular basis out there that are doing data center solutions say, bar none, if it's not cloud, that's helping to drive sales. It's this focus of on data analytics, business intelligence, and what we call big data. And ABI research here says big data spending will reach about $114 billion in 2018. Now, again, that includes software services in addition to the hardware. But one of the things they were keen on pointing out in their report was that figure includes growth for major hardware deployments around specific types of big data tasks, so like Hadoop clusters. That was a big one. So it's a growing area. It's a very important area, and it is driving a lot of interest and a lot of a need for better technology and to be able to handle those tasks and those intense sort of data center tasks. And with that, I'm going to turn it over to Bill, and he's going to talk a little bit about the Intel technology.
Thanks, Rob. So I wanted to take the rest of the presentation to talk about some tools to help you folks enable solutions that Rob was just talking about. And the bulk of the presentation, I want to focus on the latest processor we've introduced in the Xeon product family, the E5-2600B2. This processor started shipping early last month, and it's the latest in our line of dual socket server processors. So let's take a little bit of a step into what these processors have to offer when we're talking about server deployments. And there's a lot of data in here about the features that really help large deployments that Rob was just talking about. And before I dig too far, I want to make sure that I'm clear about one thing. I've got two goals here that I want to accomplish. So if you're a systems integrator and you're building your own systems, you're probably pretty familiar with our products. That's generally been our experience. we want to make sure that you've got the latest data. On the flip side of the coin, if you're selling branded systems, oftentimes we find that the processor that's included in those servers that you're selling to your clients, it's not your biggest biggest concern oftentimes, and many times you don't know a lot of the features that are underneath the hood. So we're hoping that we can share with you some of those details so that you can make a better decision, make a better recommendation to your customer when it comes to choosing a processor. So what does the E5 2600 V2 bring to the table? There's a handful of improvements and new features that we're bringing here. Number one, we've improved memory speeds. We've improved integrated I/O. We'll talk about these in a second. We've got new features with respect to virtualization and security. We've got improved performance. So we've got more cores, more threads in many of these processors, larger last level cache. And finally, 23% less power. Depending on how you measure your power, those numbers will vary, and you'll see some charts that show some significantly higher numbers in just a few pages. But the general thing that I think a lot of you are going to take away with, if you're talking about a large deployment, less power from the processor is a big savings. So let's move on. The performance that we've gotten out of this latest generation processor it's significant. It's not one of these things where I hear a lot of folks talk about it's another processor from Intel. Don't worry about it. We're just going to stick on the last generation. You'd be missing out here. There are a lot of benchmarks where we've set records. Everything from enterprise computing through virtualization, web, database, tech computing. We've got benchmarks to show that this is a platform you don't want to go and skip. Moving on to the next slide, we can see that we're getting improvement in performance depending on the benchmark you're talking about, from 10% up to in excess of 50%, along with power savings along the way. So this is a set of benchmarks we ran on our top of the line E5 2697, but the comparison to the last generation product, these aren't numbers we can ignore. So let's talk about some of the more specific features that you might want to keep in your back pocket when you talk with your customers about choosing the right processor. So we'll start with power-related issues, and again, savings of power is a twofold savings in a data center. It's not just the power that you're supplying to the servers; it's the cooling to remove that power once it's turned into heat. So there's a double-edged savings when you're talking about power reductions. Active power, we're delivering an improvement of 45%, on the order of 45% improvement in efficiency on active power. When we say active power, we're talking about the power when the server is actually actively engaged in a task. Now we have dynamic power features such as Turbo Boost that dynamically adapts the processor to the workload that it's handling at the time. So parts of the processor scale up when the workload increases and scale back and drop back the power load as the workload decreases. And of course, idle power. We have always used a little phrase that we like to say that we've got performance to get the task done and to, in a sense, race back to idle. How fast can you get the task done so that the processor can shut down and back off and lower the power consumption. So even at idle power, if the processor isn't being completely utilized, we're seeing lower power consumptions. So it doesn't matter whether or not we're loading the system or the system's lightly loaded and at idle. We're seeing significant increases in power efficiency. And like I said, that's a double whammy for customers that have large deployments. So moving along, we can decrease power center costs or data center costs using these features. And there's a couple of different ways to take advantage of that. We just talked about the power savings that are available through the processor itself, with whether it be dynamic or idle power consumption. We see savings there. But we also have tools that go along with our servers, such as Node Manager or Data Center Manager. These are both tools that can help your customer significantly save power in the data center. So you can see some of these numbers. The 23% slice of cost there associated with power in a data center, and that's the place where we can help your customers save money. The next thing I'd like to talk about is our integration with the folks at Microsoft and their Windows products. This is the first time that in the years that I've been doing server work here at Intel that I've seen a slide like this, where we have a great message where we have integrated our processors with Microsoft's operating systems. In this case, Windows Server 2012. There's a combination between the E5 2600 V2 and the Server 2012 where we can increase performance and lower operating power. And you can see this in the bar graphs here, where we see significantly lower power, on the order of 15% reduction in power, by combining those two items together, not just using the processor with an old operating system and an old application, but getting to the latest combination of processor and OS. Here's another example of a combination between Microsoft and Intel, where we're using the latest generation processor, the E5 2600 V2, along with the latest Exchange server. Compared to a previous generation platform, we're seeing significant improvements on Exchange performance. Frankly, huge performance on sending and receiving messages. So what about SQL Server and database applications? And again, we see oftentimes as much as 3x performance. Another thing that we'll talk about in a slide or two is a security feature called AESNI, and it's mentioned here. These are the security instructions that enhance data protection. It basically allows data encryption at fantastic speeds, and you'll see that in just a second. So whether it's the operating system, Exchange, or SQL Server, you're going to see performance increase, power decrease. It's a great combination. Now let's talk about bottlenecks in the platform, or potential bottlenecks. This is one of my more favorite topics because there's a great story here, and this is one of these features that can get buried in the noise, buried inside of the box. And if you're not familiar with the architecture inside of that box, your customers can miss out. We have improved our I/O architecture inside the processor. One generation ago, we changed the way we hook up PCI Express devices. They're now hooked up directly to the processor. And I'll save you the boring details of exactly how that works. But the bottom line is we can take advantage, we can better take advantage now of PCI Express Gen 3 products, more so than previous generation architectures. So especially when you're dealing with high bandwidth network adapter cards, such as the 10 gigabit adapter we're talking about here, or host adapter cards where you're hanging a lot of storage off a server, we can take advantage of bandwidth that previous generation processors couldn't. So the E5 2600 is a great example where if you're talking about storage applications or network applications where you've got high throughput through, for example, a 10 gigabit adapter, we can increase your I/O performance and reduce the I/O latency. and that's all due to stuff that's under the hood and is oftentimes ignored when people are making their processor decisions. Moving along, let's talk about security. We talk about establishing a foundation for secure computing through what's really a three-part or a three-legged stool. First, we have AES-NI. These are encryption instructions that are built into the processor. And on the next slide, you'll see the fantastic results that AES-NI delivers. So first, we enable better encryption, more performance in data encryption than there has been available in the past. And that opens doors to doing things like whole disk encryption or getting better performance on SSL encryption than previous generation servers could do. The next thing is we have TXT to help enforce security policies, establishing trusted status or trusted compute status within a server. So this enables implementation of security policy and secure workload control. And finally, using our virtualization technology instructions, or what we call VT, we can protect and isolate virtual machines in a virtual environment. So those are the three legs of the stool. And if you combine that with applications like, for example, here on the slide, we talk about the Apache Hadoop, we can deliver more security and better performance than what we could in the past. So again, I keep going back to the theme of looking at past generation platforms. Maybe your customer's got a platform that's a couple of years old. It's time to consider getting them a new one. There's enough new in the way of features and performance out there that they really need to be considering these new platforms. So I promised you a slide on AES-NI and the security encryption, and here it is. So what you can see is speed of encryptions and decryptions. You can see a 5x performance increase over previous generation or processors that don't have AES-NI. And on the decryptions, that's where we get some fantastic results with a 19x improvement performance. AES-NI is one of those wonderful gems that we put into the processor that not a lot of people know about. But for those of you who have customers that are doing work that require encryption and decryption, this is a fantastic feature. All right, let's move along. I want to talk about the SKU stack just a little bit because that was one of my goals here, is to help you understand some of the choices that you can make when you're selecting a processor. In general, when you talk about Intel Xeon processors, the dual socket parts, our family typically comes in 4 levels. I'm not going to say this is the lowest level. It is a category of processor we call low power. There's usually a couple of SKUs that have lower power consumption than the rest of the product line. Then we step into the meat of the product line, the basic, the standard, and advanced SKUs of which we offer. Now, if you've been around the industry a little bit, you can remember the days when the Intel processor stack, each processor differed from the next only by clock frequency. So as you moved up from a 5650 maybe, it's not a great example, but if we move back to a 5200 series, a 5210 to a 5220, if you moved up that stack, the only thing that would change would be clock frequency. But that's not the case anymore. These families of processors all share basic characteristics. For example, the basic SKUs have 4 cores on board. If you moved up to the standard SKUs, they'll have 8. The advanced SKUs have up to 10 cores. And then you can get even more than that in the optimized high core count SKUs. Memory speeds change and they increase as you move up the stack. The QPI, or the interconnect speed between the processors, changes and improves as you move up the stack. The biggest thing in my book is hyperthreading. Those basic SKUs down there, those are the least expensive SKUs. We don't sell a whole lot of them. People typically make the choice to go with hyperthreading and to buy the hyperthreading-enabled SKUs in the standard SKU lineup. That's, again, if you're not familiar with the platforms and you buy into that basic SKU level, you're missing out on a lot of performance potential there with hyperthreading. Again, Turbo Boost. You don't get Turbo Boost in those basic SKUs. If you move up to the standard SKUs, that's where you get the Turbo Boost enabled. You get better Turbo Boost performance as you move up the SKU stack. Last level cache size changes, as well as the power consumed, as you would expect. But the point that I want to make sure you understand is that in general, the last 1, 2, 3, this will be the 4th generation of platform where we've used these families of Xeon SKUs. If you don't want to memorize the whole SKU stack, I understand that. But just understand that there's choices to be made as you move up and down that stack. And it's more than just clock frequency, much more than clock frequency alone. So let's move on. I wanted to give you a quick glimpse at the actual SKU stack. And this is actually a transition guide. If you've got customers that were using the previous generation E5 2600 family, this is some guidance on transitioning from the 2600 to the 2600 V2. But if you look on the left side of the slide, or the right side of the slide, I'm sorry, you can see those individual SKUs contained in each one of these families, whether it's the basic, the standard, the advanced. Needless to say, probably the most popular SKU we see is the E5 2620. That is it enables hyperthreading and Turbo Boost. It gives you the basic features that most customers want. The second most popular SKU that we see is the E5 2650. Again, that gets you into the advanced SKU segment where you get the fastest memory speed, the fastest QPI bus speed, the fastest performance on Turbo Boost. It gets you the fastest of the basic features. The only thing that you can improve at that point is clock speed and potentially core count if you go up to the top of the SKU stack. So I don't want to belabor the point. This is a good piece of reference if you want to go back and take a look at the whole stack. But please do understand that there's more than just clock frequency available to you as you make a choice to move up the SKU stack. Now I'd like to change gears just a bit here and move away from the processor. There is quite a bit of hardware inside a server that comes from Intel, and it's more than just the processor. And I'd like to talk about all of the other components inside an enterprise-class server that come from Intel. And one of the reasons why I think you ought to consider all of the other components that we offer inside a server, if for no other reason, it's a one-stop shop. There's no more games anymore. If you buy a RAID card from Intel and you're using it with an Intel platform, there's no games of trying to figure out whether or not the RAID card is supported with the motherboard. It is, and there's only one person to talk to. It's one throat to choke. There's no fussing about whose problem a problem might be. It works great, and it works together better together. So let's dig into this a little bit. Start by talking about the ingredients that we have to offer. So up in the upper left-hand corner, we've got the processors that I've been talking about. We have more than just the E5 2600 family. We've got single-socket products with the E3. We've got multi-socket 4 and 8-way socket products with the E7 family. In addition to the server processors, we've got the server platforms, chassis and motherboards from the folks in our EPSD division. They actually do chassis, motherboards, RAID cards, most of the major infrastructure associated with a server outside of the processor. For people doing high-performance computing applications, we've got the PHY coprocessor component. This is a very specific tool used for high-performance computing applications that can have as many as I believe it's 50 or 60 cores, depending on the SKU you buy, on board. This coprocessor. And again, I have to emphasize, this is not something that's supported by off-the-shelf software. This is very specifically designed for high-performance computing applications where customers are developing their own software. Moving along, we have fabric choices. We've got 1 gigabit. We're the most popular supplier of 1 gigabit cards in the industry, but we also have a fantastic line of 10 gigabit products. 10 gigabit is turning the corner, and the adoption is really starting to kick into gear. We've got a great line of products here. We also have, for high-performance computing applications, TrueScale InfiniBand architecture products. We have a portfolio of software products, including McAfee for security. Products like Lustre, again, a high-performance computing application. We've got Parallel Studios and Cluster Studios, along with our line of compilers, and also the power management and node management tools that I mentioned earlier. So there is a broad line of software products that we have to optimize the performance of these platforms. Finally, we've got a wonderful line of SSD cache, SSD storage products, along with caching software. Our caching software is a fantastic application, especially in enterprise environments, where you can create a multi-tiered storage platform using our caching software, our SSDs, along with rotating media from other suppliers. So that's the high-level view. Moving along, the platforms. I want to make one mention of the platforms here. Intel has a complete line of server platforms, both rack and pedestal, along with RAID cards to support the E5-2600 V2 processor family. It's been out there, it's shipping, it's BIOS compatible. So if you've got an older platform that's using the E5-2600, the previous generation, you can upgrade the BIOS and put the V2 processor into that platform, or just go out and buy the E5-2600 compatible platforms today, and they're BIOS compatible with the V2 processors. So it's a great family of products. Moving along, we've got a complete line of RAID cards. These RAID cards are based on LSI technology, so we jointly developed them with the folks at LSI. We've got everything from basic RAID built onto the motherboard to entry-level I/O controllers to what we call ROC controllers. In other words, controllers that are specifically designed to work with our motherboards. And we have expanders and SSD cache modules. So we've got everything from entry to high-end platforms like what we call our Zia Beach or our 1 terabyte cache module card that can really do some kicking stuff to your application performance. And we've got software tools to help optimize performance when you're using some of these high-end platforms. All right, let's keep moving. We have a family of products for data center SSDs. We start with a 3500 series platform, which is a broad line of platforms, probably the most popular data center platform that we have, the 3500 series. It's available in, up to 800 gigabytes. That's right. We've that's a basic high performance standard endurance platform. Now, if you're looking for something that has high endurance, high write endurance, SSDs, you can move up to the 3700. So these two platforms represent a nice two-tiered storage solution for enterprise SSDs. And finally, we've got the 910 series platform for it's a PCI SSD solution with just killer performance. You're not bottlenecked by the 6 gigabit interface with the SSD. So the 910 series at the top, 3500 at the bottom, 3700 in the middle. We've got a complete line of SSDs to meet your data center needs. And finally, the TrueScale Fabric portfolio. We've got a wonderful example of interconnect for high-performance computing customers. These are folks that need low latency, high bandwidth interconnect. So I'm actually getting a step ahead of you here because I didn't hit the so TrueScale. There we go. I'm sorry. Now let me give you an example of what you can do with all these pieces in this platform story. If we're not just talking about the processor, let's take a look at an application that we used. It was a 1 terabyte sort application using I guess this would be a 2-generational platform, a Xeon platform using the 5690 Intel Xeon processor, and a rotating media hard drive with a 1 gigabit adapter. This is an application that took 4 hours to complete with the 2-generational platform. So let's move up and bump us up to the latest E5 2600 based platform. And we see that performance increase by 50%. Now we're going to throw in an SSD into the mix. This is an older generation SSD, but we're basically talking about the potential of moving out the rotating media and replacing it with SSDs. Again, there's another 80% improvement in performance. We move to 10 gigabit instead of 1 gigabit. We see another 50% improvement in performance. And finally, we're going to move to an Intel optimized Hadoop software distribution, and we finally take that down another 40%. So we take an application that used to take 4 hours, and we've moved it down to 7 minutes incrementally by taking a look at what are the best optimized pieces in the Intel platform and portfolio to do the job at hand. So it's more than processors that you should be thinking of when you're thinking of Intel. Think of the SSDs. Think of the gigabit adapters or 10 gigabit adapters, and our software portfolio, and our platforms, the motherboards and chassis as well. So I'm going to wrap it up by saying that we have a lot to offer when it comes to putting together platforms for the data center. Whether or not we're talking about the operational excellence for delivering power efficiency, for power efficient operations in large deployments, we're talking about customers who are trying to modernize their service delivery, or we're talking about new opportunities that we haven't even talked about here today. We've got platforms that really work for your customers. So on that note, I haven't been watching the question queue, but I don't see any questions in here. This is a great opportunity. I've got a couple of folks on board that know far more about some of this technology than I do, that are here to answer your questions. If you've got questions about the processors, the platforms, or any of the other components we talked about, feel free to go to the question and answer tool and submit your questions.
Okay, Bill, so I'm taking a look, and actually we do have a couple of quick questions, and before we get into that, I'll just quickly push out a brief survey, as I promised at the beginning of the presentation. If you have your pop-up blockers enabled, then you won't be able to see this, and if that indeed does happen, just send us a quick note using the Ask a Question feature, and I will re-push that out as we move forward. First question is coming in from Dave. Will existing Intel server platforms accept the new E5 2600 V2 processor? Bill, that's directed at you.
Yeah, thank you. Easy one. The answer is, in short is yes. The V2 processor is socket compatible with the previous generation, the E5 2600. Now, depending on whether or not we're talking about an Intel platform, if you're purchasing a brand new Intel motherboard and/or system, the answer is yes, it'll work. We always recommend you upgrade to the latest BIOS, but that's the bottom line. If you're talking about a branded platform, say an HP or an IBM, and it's an existing platform that's out there today, again, if it's a 2600 and you want to put a 2600 V2 processor in there, more than likely check with the manufacturer, but more than likely get to the latest BIOS release and it will be supported. It is socket compatible.
Okay, next question is coming from Tracy, who's asking, is this more speed and fees for Intel processors?
I wish I could get back to Tracy and ask a little bit more about what that question means. If it's a comment about is this a speeds and feeds presentation, I consciously tried to make this presentation a little bit more about speeds and feeds than I might typically do so. If there's other information that you need from us that you'd like to hear, we're available. I don't know if there's a way to get my email contact information through this webinar, but please let's work on getting a hold of myself or one of your disti reps. Your disti reps can get a hold of me, and I'd be more than happy to get you the information you need if I didn't give it to you here today.
Yeah, so Tracy, if you have a follow-up and you wanted to ask it here, we got a few more minutes. So if you wanted to follow up with something specifically for Bill, you can do that as well. Question: what benefits do I get from using the processors higher up the stack?
This is a question that I tried to answer. There's a guy here. David, this is David Borden, who's one of our technical experts, and I happen to have the benefit of having him here today. Did you want to take a crack and give your opinion at the benefits of buying up the stack, or do you just want to leave that one to me?
Yeah, sure, Bill. One of the greatest benefits now of moving up the stack is all the additional features that you get going from our lower class processors up to our advanced processors. Not only do you get the frequency, but as Bill had mentioned earlier, you get additional frequency, you get hyper-threading, you get increased memory speed, in addition to the frequency, in addition to higher levels of turbo. So you really get, as in previous, several years ago, when you bought up the stack, you got small segments of frequency. But again, we really give you a lot of value as you go up in the frequency. And looking at all the performance data that Bill talked to, you'll see that we give you definite value with those features.
Hey, thanks, David.
All right, very good. Any final thoughts, Bill, before we wrap up today? It doesn't look like we have any more questions, so I'm going to give folks a little bit of time back. But if you have any final thoughts, we'd love to hear that as we wrap up.
I'll just throw one thing out there. Again, if you're a reseller who doesn't build your own, you're selling branded hardware, I want to make sure that you understand that there's an army of Intel folks out there that are more than willing to help out with you if you're trying to close a sale with a customer. These aren't people who are out there trying to get you to necessarily sell up or buy something you don't want to buy. We're out there to try and help you close a sale on whatever Intel product it is that you're selling. So if you've got questions, please get a hold of your disti rep. Get a hold of them. Have them get a hold of me or one of the local Intel reps. we're here to help. It's a resource that not a lot of people take advantage of, but I think you'd be surprised what you can find from us or the help that you can get from us if you look us up. Thanks.
Very good. We certainly do appreciate your time today. I want to remind our audience that if you missed any portion of today's channel cast, it will be available in its entirety on demand. And speaking of on demand, you can find a great library of past, present, and future channel events by liking us on Facebook /channelcast, or you can go to crn.com/channel-cast/index.htm, and there you will find all of the events that we've done here and a whole lot more to offer you. I want to thank my guests, CRN Managing Editor Rob Wright and Bill Elwell, Intel Server Channel Manager, for being part of today's conversation. Guys, really do appreciate all of the information that you gave us today from both the editorial perspective and then taking a deeper look at Intel. So thanks so much for being with us today.
Yeah, thank you, Jonas. Thanks, Bill. And thanks, everyone, for tuning in.
Have a great day.
Yep. My name is Jonas Tishner. For all of us here at the Channel Company, I want to say thanks so much for watching, and we'll see you next time.